is the Network's Access Control List. People call NACL, NACL. We can call it any way we want. So these Network Access Control List. So anyone from a network background probably already grasped what this is. So this looks at traffic management at a subnet level. So this defines who can access, in what way they can access a particular subnet. So it doesn't really specifically focus on the resource itself. That's the security group's job. But to something to get to or not to get to a subnet, their NACL plays a role. So they provide network control at the subnet level. So that's to and from the subnet. The default NACL allows everything inbound and outbound. So as you have this default VPC, default subnet, so we would also have a default NACL. So we have a default NACL. And if you actually look at it, 100, all traffic allow. So that's the default status of an NACL. So as you can see, by default, your NACL, so the default NACL within your default VPC, by default, allows all traffic. So you also see something here that says star all traffic deny. So this is basically a common statement we use as a rule for if the traffic does not match any of the rules defined here. Probably you could have hundreds of rules here. If the traffic does not meet any of them, then that's denied. So that's what this means. So the default NACL allows everything inbound and outbound because this is a stateful, right? So let me show you the other way as well. So we looked at inbound, we should also look at outbound. So same thing allowed. Unlike the security group, which are stateful, these are stateless, which means you have to define a particular traffic either to be allowed both for inbound and for outbound separately. Let's look at the ping example we looked at before. So the user pings your EC2 instance. Say, for example, if you have your NACL configured for the traffic to allow, it then allows it to the subnet, and then the security group allows them further, goes to instance, get the response back, comes back to security group, passes back to NACL. Unless we have explicitly allowed the outbound traffic, the ping will not go back to the user. So that's the difference. Security group, if you allow one way, the other way is automatically allowed. NACL, we have to manually allow or deny both ways separately. That's a key difference, and that's an improved security offering. So again, they support both allow and deny rules as we saw here. So we can both define two parameters. NACL rules have numbers. So if you notice here, the rules have got numbers defined. Generally, AWS recommends an increment of 100. So if you have a rule as 100, the next rule need to be ideally 200, 300, 400. And the lower the number, the higher the priority for the rule. Say, for example, in this example, we have got 100, and that says allow. And for example, we have a rule number 200 that says deny. The end result is going to be that it's going to get allowed because rule number 100, which has higher precedence, will allow the request. So that's why it's important to, when you're reviewing or creating these rules, to make sure the numbers are reflecting the importance of the rules or the weightage of the rules. So when you create a custom NACL, NACL. So when you're creating your own VPC, then you have to create your own subnets and everything. And when you create your own NACL, by default, everything is blocked, denied. So the difference is the default NACL allows everything inbound, outbound, but the custom NACL that we would create will deny everything by default. We have to explicitly allow them if need to be. So they are stateless as we looked at before.